Thank you very much. Thanks for having me, and thanks for having me remotely. And special thanks to Thomas, Ake, Sergio, and Amanda for this. So I'm going to tell you about this new course on observational astrophysics that we have started at the Norwegian University of Science and Technology. This is a course that includes an observing project with the Nordic Optical Telescope. Well, first to put Trondheim and the Norwegian University of Science and Technology in the map. We're here in Trondheim, in the lower third of Norway. And to give some context for this course also, this is a first-year master's course, or with some flexibility, also including third-year bachelor students, all in physics. And the motivation that we give to the students at the beginning is to look at the sky to learn physics, and then the observational part is really how to look at the sky, and that of course implies scientific methods, instruments, and techniques that have to be learned and used and applied thoroughly. And this is the goal of this course, to teach them how to do this. There's also other courses that I want to mention at the NTNU in astrophysics, taught by my colleagues that you see here. So there's several other courses in our curriculum in astrophysics. And this was a new course that started now in January 2022. So that gives the context. The contents of the course are, well, first there is a first block which deals with the fundamentals of observational astrophysics. So this is not something that they have seen before, so we have to introduce to them, the basics, and you'll see more details of what the basics, what I mean by the basics. And then there's a section on telescopes, collecting and focusing light. And then there's a section on detectors, recording and measuring light. And we also have a section here in this first block on multi-messenger astronomy, taught by my colleagues Michael Unger and Kachelbis in the group. Then there's a second block or part of this course, which I call AstroLAB sessions, which really focuses on data analysis and astronomical techniques. So here they have between 3 and 4 sessions, about 1.5 weeks each, and really hands-on sessions on data analysis in the computers. And then after that, they deliver one report after each of these sessions. And then the third block, and most important for this talk and for this workshop, is the observing project at the Nordic Optical Telescope. So these are remote observations at the NOT that I'll describe with some more details soon. So, but the goal of this third block is really to give them a research project to do with a real and professional telescope like the NOT. So then also they work on, writing skills, their scientific writing and teamwork and these kind of things. And then they deliver one proposal and one little article with the results per group. So these different parts of the course happen in different places. So we started remotely due to COVID, but soon, fortunately, we could go to the classroom. And then the first block, really on the fundamentals, is in a normal classroom, let's say, and with normal lectures, so theory and problems. And then these are some of the things that are meant by fundamentals. So fluxes, magnitudes, faculty radiation, redshifts, So you can see a list here. I'm not going to go through all of that. But then one of these lectures is taught at the planetarium in Trondheim, and that is the one on the celestial sphere, movements, and coordinate systems. So, we thought that it would be a good place to teach this in a planetarium, because then you can really see very easily the different coordinate systems. And then the third part is in a different room. So this is our Linux lab with about 40, 50 Linux computers. And there we installed several suites of astronomical software for the students to work on the data analysis. And then these are the lab sessions that they did this year: optical photometry, optical spectroscopy, and then X-ray timing. And there is another one on X-ray imaging that is in the making, probably for following years. All right, so really the observing project and the part that brings me here is for now limited to outforce imaging and long slit spectroscopy for simplicity. Maybe we open for new instruments and modes in next years, but we'll see. And then they choose a target: white dwarfs, AGNs, neutron stars, from a set of catalogs that we distribute to the students. They do this between February and March, and then they plan and propose their observations. So that's done between March and April. And they write an actual observing proposal with the template of the research proposals at the NOT, which, by the way, I've also used for research. I haven't mentioned, but I also use the NOT for research for other topics. So they just write little observing proposals, and that's also a good exercise for them to learn how to do this. And then, if this moves on, they finally observe 3 nights. April this year, it was between April 20 and 22nd. And they observe remotely from the room that I showed you. And then they analyze and report the results of these observations, and they do this in May. So this is a picture of one of the groups during one of the nights, and this was big thanks to Ake for the support during those dates. Well, you see they have this big screen where they project the observing system, and they with the help of Ake and my help in a few smaller things, they run the observations themselves. And this is probably familiar to many of you if you've observed with a NOT before. And then they analyze, as I said, and they write reports. So this is a sample, the abstracts and titles of 4 or 5 of the reports: optical photometry on cataclysmic variables, photometry of another cataclysmic variable, a polar, I think this is, and then optical photometry of a redback millisecond pulsar, and then tick-tock goes the black hole clock. This group took a spectrum of the tick-tock supermassive black hole binary candidate, let's say, and then state determination of the transitional binary millisecond pulsar. So, you know, it's nice to see how they go from 0 to writing these little papers in a semester, which is what this course lasts. These were the grades freshly out of the oven. I just corrected all the reports and exams. They also have a final exam, and these are the grades. And just to give you a sense of the feedback that I got, of course, the observations with the NOT, the best part of the course. Probably the coolest thing that I have done in my almost 4 years of higher education. So they really like this, and they really enjoyed that. And then the worst part of the course, if you see here, one of the comments was not going to La Palma physically, and I can understand why that is the worst part for them, but for now, the plan is to keep doing this remotely for logistics. And that's it, really. The summary is that we have a new course on observational astrophysics at the Norwegian University of Science and Technology in Trondheim, Norway. And I've told you this 3-pronged approach with lectures and then data analysis labs and then the observing project at the Nordic Optical Telescope. And then the plan is that we'll be back in 2023A in the spring next year. So we will, I will propose again for time for this project and for this course. And then thanks a lot, and thanks a lot again to all the ones involved in making this possible, and to you for listening.